Hi, derivativites. Okay, so as I was saying before, I was so rudely interrupted by the end of the last video. So I noticed that G prime is positive everywhere that I've shaded in green because it's above the x-axis. And that means that the slopes are positive because they're in the positive section of y. And so that's happening from a domain values of negative infinity to -2. So all of this stuff from here back to here is when I'm going to have positive, because keep in mind this would go forever. And then same thing is happening over on this side. So starting here and then going forever out to infinity. So that's why I have 2 to infinity and negative infinity to -2 on the left. And then I noticed that g of x has negative slopes because these are negative y values everywhere below the x-axis, and so that's from -2 to 2. And then I noticed that g of x has 0 slopes when it actually falls on the x-axis, because g prime of x would be 0 here, and g prime of x would be 0 here. Those are the y values, and so that's where it has 0 slopes. Okay, so now we can answer the questions. So for this first one, if I know that g prime is -8/3, remember this is a slope. So what do I know about the original graph? If the slope is negative, well, the slope would be negative when it's going down, right? So I'd have to know that g is decreasing or going down. Decreasing is the fancy word. Drink your tea with your pinky up, kids. And on the next one, what do I know about the graph of the original function g if I know the slope at -4 is positive? Well, if the slope at -4 is positive, then the function would have to be going up to have a positive slope, so I know that g is increasing. And so for this last piece, well, let's see. G of 6, the slope at 6 is positive, it's up here, and the slope at 4 is also positive, but this one would, the G of 6 would actually have a steeper slope than the G of 4. So it would be a larger positive minus a smaller positive, and that would give me still a positive slope. And that's what I just said, all with symbols. So they're both positive, but g of 6 is, the slope at 6 is greater than the slope at 4. So when I subtract their slopes, it'll be positive. So g of 6 minus g of 4 will be positive. So this next one is a bit tricky, isn't it? So I'm supposed to use my knowledge of the graph of, what is this? That's right, it's a line. I'm supposed to draw the graph of the derivative, but the derivative is nothing more than the slope. What's the slope? Oh, the slope is 2. So that means my f prime is -2, which would look like this. Guess I should put some numbers on here. So there we go. -2. Easy peasy. Okay, so on this next one, I got to match the function with its derivative. So remember, over here are the slopes, and over here is the original function. So if I think about what's happening with the slopes of the tangent. So if I draw a bunch of tangent lines, so first they'd be negative. Then all of a sudden, the slopes would start being positive. And then all of a sudden, they'd be negative again. So I need to check over here where the slope's negative. So they'd have to, this graph, I'd have to be below the x-axis. So let's see, negative, yeah, I got that here, I got some here, let's see. Then they turn positive for a while. So let's see, I'd be positive up here, and I'm definitely positive up here. And then I turn negative again. Well, this graph, there ain't nothing else there, but this one over here, oh look, now I'm back down in the negative. So I've got negative, positive, negative. Looks like that's a fit. So number 2 goes with A. See you on the next video.